Alright, here we go. This algebraic reasoning 1.3, example 1. Each year during the growing season, trees grow by adding another layer of cells just beneath the bark. The layer is called a tree ring, and it can be used to determine how old a tree is. We're all used to this. However, not all tree rings are the same width. Trees grow better when there is plenty of water and fertile soil. Mariette measured the width of a tree rings from the core sample she took from a post oak tree near the Brazos River. The table shows her results. So basically, these are tree ring widths. Okay, so it says calculate the finite difference between the years and the given radii. All right, for both the years and the given radii. Well, hopefully, real quick, you can notice that these are all plus 1, plus 1, plus 1, plus 1, all the way down, plus 1. So the x values don't change. The y values, however, 3.5 to 0.1 is 0.6. This one is 0.4. This one is 0.4. This one is 0.5. This one is going up 0.5, and this one's going up 0.6. All right, so those are the differences. All right, and then the next one says if they are not consistent, calculate the average finite difference. So basically, here's what we're going to do: to find the average y, which this little bar above the top is just a different way of saying average of that variable. So that's the average y. We're going to do 0.6 plus 0.4 plus 0.4 plus 0.5 plus 0.5 plus 0.6. 1, 2, 3, 4, 5, 6, 1, 2, 3. Okay, I didn't miss any. All right, and we're going to divide it by 6. There are 6 differences, so we're going to add those up and divide it by 6. Give me just a second. All right, and that equals 0.5. Came out to a nice even number. Sometimes it comes out to a crazy number, and you just have to round it off best you can. It says use the average finite difference to create a linear model. Okay, so we need 2 things, remember. We need the average rate of change. So that's the differences in y divided by the differences in x, which in this case is 0.5 divided by 1, which is just 0.5. All right, so there's that. And they actually gave us the starting point, which is really nice. We don't have to calculate it. So the starting point, the x of 0, equals 2.5. So let's go ahead and write our equation. Y equals, I'm going to go ahead and put 0.5x plus 2.5. And that's your equation. Right? For this equation, what do the slope and y-intercept represent? All right. Well, semantically, the slope, so it's change in y divided by change in x. Basically what that means, it is y, whatever y is, per whatever x is. Okay? So in this case, it is the growth of the tree rings which that is what y represents. It's the growth of the tree rings, the radius, per, let's keep it the orange, per, and then x, per year, because that's what x measures. It is whatever y is measuring, which is growth of the tree ring, or you can say the radius of the tree ring, however you want to use that, per year. Okay, so that's the slope. I didn't put that in a sentence. So let me erase this. I'm going to back up a little bit. Slope represents, all right, the y-intercept, okay, represents the tree ring width width at the beginning of measurement. Okay, and here's what I got. And there's different ways of saying this as well. It's the y-intercept represents the tree ring width, because that's what the y-intercept is measuring. We're measuring a width at time 0. We're measuring the width at time 0, so it's the width, that's the ring width, at time 0, which happens to be the beginning of measurement. Alright, so, and that's that. Alright, I'm going to pause and move on to the next section. Alright, basically this is the same problem, but, and I copied the equation over so we could see it here. It says use the model to predict the radius in 2016. Okay, well, 2006 was number 6. So when at x of 6 represents the year 2006, doesn't equal 2006, but that's what it represents. I'll put colon there because it's not equal. Well, then we need x of 16 to get 2016. Alright, so what we're going to do is plug in 16 in for x. So y equals 0.5 times 16 plus 2.5. What's 0.5 times 16 is 8. 8 plus 2.5 is 10.5. So we are estimating that the tree ring will be 10.5 centimeters they're measuring in? Yep. So 10.5 centimeters in year 2016. It says, what year will the radius reach 12.5 centimeters? Okay, so 12.5 centimeters, same idea, but what we're going to do, y is measuring the width, so instead of plugging in for x, we're going to plug it in for y. So, here we go, 12.5 equals 0.5 x plus 2.5. Okay, so we have a two-step equation. Always going to start whatever's added or subtracted, then deal with the multiplier. So to move a positive 2.5 over, I'm going to subtract 2.5, and you get 10 equals 0.5x. The 0.5 is multiplying, so I'm going to divide by 0.5, and in this case, x equals 20. So we'll be in, it says what year? Well, that's in year 20, but year 20 would be the year 2020. That will be the year it reaches 12.5 centimeters. Use this model to estimate the circumference in 2015. Okay, well 2015, first of all we got to find the radius. Okay. Circumference, if you remember, circumference is how far around, what is the measurement on the outside of the swing? We can use our equation to get the radius. This is what our equation gives us, is that radius right here. Alright? So we need to find the radius, and then we use the radius to find the circumference. Alright? And the equation for circumference equals pi times the diameter, which if you recall the diameter is remember it's, the diameter is 2 radii. So we're basically going to go C equals 2 pi r, because the diameter is 2 times r. Alright, so first we got to find the radius, then we use that to find the circumference. So in year 15, alright, so again, 2000 is represented by x of 0. Is represented by x of 0. So for 2015 is represented by x of 15. Okay, so here we go. Y equals 0.5 times 15 plus 2.5. Well, 15 times 0.5, or half of 15, is 7.5 plus 2.5. So that's 5 plus 5 is 10, 7, 8, 9, 10. Y equals 10. So we have a radius of 10. That's our radius. So to find the circumference equals 2 pi r, but instead of radius, we're going to put in a 10. And then 2 times 10 is 20. So the circumference is 20 times pi. And I'm going to leave it. And remember, everything was measured in centimeters, so we'll leave it in centimeters. And I'm going to leave it in terms of pi. Okay? Not going to. We could multiply 20 times pi, so 3.14159. So that's going to be 20 times 3 is 60. It's going to be about 62 point something. All right? But this way we leave it in terms of pi. This is actually a more accurate number than, well, let's just crank it real quick. 20 times pi, oh gosh, 20 times pi is 62.8. So even if it goes 62, so even if we say 60, circumference is 62.83, and then we'll round here, 2, we still have lopped off the rest of the number. So this is not as accurate as that. Sometimes you need to keep as accurate as possible to the very end, and that's when you round. This is not that place. All right. Anyways, last one, we'll keep on going. Estimate the area of the tree's cross section in 2025. Okay, it says the area. So we've already done the circumference. Let's do the area. Well, remember area. That's all of this. We use the radius to find the area. And the area of a circle is pi times the radius squared. So first things first, we need to find the radius in year 2015. So here we go. Y equals 0.5 times 2025. So that's an x of 25. If you're wondering why to 25, go look at the last problem as to why it was at 15. That'll answer that. Plus 2.5. Half of 25 is 12.5 plus 2.5. So y equals 25. All right. Then to find the area of the circle equals pi times my radius, which is 25, squared. Well, 25 squared is 625, so that would be 625 pi. And we're just going to leave it in terms of pi, just like that. Okay? And there you go.